What's up, guys? I don't want to do another video with you guys here. I want to do another Ethernaut challenge, and we're going to do number 4, which is telephone. This is the final one for level 1 here. They might add some in the future, but right now we've done every one for level 1. All these other ones are level 2, 3, or even 4. So without further ado, we're going to click on telephone. Of course, I solved it off camera, so we're going to get a new instance here. And we're going to click on confirm. I don't know why mine still says T-Fuel. I am connected to the Grelly network. I think it's just a little caching issue with MetaMask. And once we have a new instance, some of this information here should change because I believe it's showing some of the information that's there after you solve the puzzle, or excuse me, the smart contract. Request a new level. And this one's interesting because this is actually something I didn't know before here. If we just look at the contract, we have pragma solidity greater than 0.8, contract telephone, address public owner, constructor, owner equals the message sender, and then we only have one function in this contract. We have function change owner. This takes in an address. It is a public function, and if the transaction origin is not equal to the message sender, we're going to change the origin from here. So if the origin is not the message sender, so what does that mean? Well, I'm going to go into remix. There we go. That's what we want to see there. Where was that? We're going to go to remix. We're going to talk about this a little bit more here. Claim ownership with the contract to complete this level. Things that might help. See the help page above beyond the console. So basically what we have to do for this one here is we have to call this function not from the message sender itself here. So if we go into remix, we're going to make a new contract. In fact, that shouldn't even be there. That's for a different, yeah, we'll keep it there right now. Why not? Let's call this test1.sol. And then we'll make another one called test2. And just to make this a little more simple and speed up the process a little bit here, I'm going to copy this here. And let's paste this. And let's actually rename test1. So I'm in test1 here. Let's rename this to be... Come on now. Can't change... Oh, rename. I'm in F2. This will be... telephone.sol. And this will just be test.sol. And rename. Cool. Let's go inside. We don't need this one here. We don't need storage, and we don't even need home here. Let's go inside test, and let's remove almost everything here. And let's rename this to be test from there. So now we have an environment working and kind of set up from here. If you guys aren't familiar with Remix, you can definitely work with a VM or virtual machine kind of blockchain where you can deploy contracts with the VM here. We can do different things, or we can interact with them. But if we want to interact with contracts that are deployed on a smart chain, or excuse me, the blockchain, so if we want to interact with smart contracts on the blockchain, we can actually do that too. We can use our remix as sort of the portal to connect with that blockchain. So I'm connected to the Relay test network. If I drop this down here and I go inject a provider MetaMask, I can actually connect to this contract that I just called here through my remix from here. So this contract is the same as telephone. So I'm going to click on telephone. I'm going to go ahead and save that. It's already auto-compiled from here. And I can load this contract at a certain address from here. So what I can do is I'm going to go to the address that was here. And I'm going to copy this. And I'm going to paste this right here. And now we're able to interact with this contract, which is the same as this from here, right? If I go to the owner, we can see that this owner is FE22FE here. This is the same that if I said await contract.owner, just like that there. Right, same address from there. So that basically, it doesn't 100% confirm that it's the same contract, but we can kind of see that it's the same contract from there. Anyways, from here, what we want to do is let's talk about the difference between the transaction origin and the message sender. So let's go ahead and set up a function. We're going to call this origin. And what we'll do is we won't take in any parameters here, but we're going to returns. First off, let's make it public. This might be a view. We're going to say returns. And we're going to return an address. And we're going to open up this contract from here. Now for this particular contract, we're just using this for, actually I take that back here. What I was going to say is you could go back to the VM to save test ether, but we're going to use this to interact with this contract in a second. But anyways, from here, what we want to do is we're just going to return the msg.sender. Tell you what, we basically know what's going to happen here. If we just return the msg.sender, it's going to be whoever called that contract from there. Let's rename this to be return sender. We're going to make another one from here. We're going to say function. We're going to say return origin. Public view returns address. Open the curly braces up. We're going to return the tx dot origin. And I believe I made a typo there. So let's go ahead and add our curly braces. And then we can put this inside of the curly braces from here. Save. Cool. So now we have our telephone. I'm going to collapse this contract down here. And we're going to deploy this test contract from here. So let's go ahead and deploy this. And we're going to confirm the transaction through MetaMask. Confirm. And this is going to take a second here. Cool. So that's confirmed here. Now we have our test here. And if we go to return origin, this is the same wallet that's right there. And the return sender is the same. That's the opposite order, but that's okay. I'll tell you what, this won't change. Obviously, the contract's deployed on the blockchain, so we can't change that data. But this won't really change anything here except for making it the same here. So return origins on top, return senders on the bottom from here. So what gives here, right? Well, because this wallet is calling both these functions from here, it's both the transaction origin and the message sender. Let's go back to our files here, and let's make one more new one. I actually did this earlier. I could have kept it, but that's okay. Test.sol. And we're basically going to copy this contract test, and let's paste this from here. Now we're going to remove both of these things here, and we're going to call this test2 now. And we're going to save it here. Now at the very top here, what we want to do is we want to import test into this contract from here. We want to be able to interact with the ABI of this contract with this contract right here. So beneath Pragma Solidity here, I'm going to say import, and this is another lesson on how to import scripts into your contract or smart contracts into your contract from here. What you could do is you could actually just copy this whole thing here, and you could do it like that. That actually works fine. What I'm going to do is I'm going to do it the more common way you see it here, and I'm going to actually use double quotes, // which is the same directory that you're working in here, and I'm going to import test.sol, and we need to add the semicolon. Now, before we're in any function from here, we're going to say test. Come on now, test. If I can type test, public, and we're going to call this test, lowercase. So we're creating a variable within this contract that's an instance of this test smart contract from here, all right? Now, what we want to do is we don't want to just have any instance of that. We want to connect it with a certain address. So on the constructor function, constructor, we're going to open this up here. We're going to say test. Now, what we're going to do from here is we're going to say test. So we're referencing this variable from here is going to be equal to capital test, an instance of this contract from here at a certain address, semicolon. We're going to copy our test address here. I maybe should have chosen some better variable names or smart contract names here, but that's okay here. So this connects this variable with this contract that's deployed at this address from here, right? And if I go to, let's just do this here. Let's go back to our first contract. Let's go ahead and copy both these from here. And let's say, let's paste that right there. So hopefully this isn't too confusing from here. I don't know if I've been super clear. Oops. Instead of just return the origin on this contract, I'm going to call this function on this contract from here. So let's go ahead and rename this to be like, test return origin. And what we're going to do is we're going to say test.return origin from here. And we're going to return that from there. Same thing over here. Test return sender. Return test.return sender. So remember, these functions, even though they're in this contract, they're calling these functions on this smart contract from here. It's almost piggybacking in a way. If you end up working with, a lot of different things here, but specifically one of the things I saw this a lot is with Uniswap. A lot of times you can't just, you don't have the ability to just reference, how do I phrase this right? You have to go into their contracts that are deployed on the blockchain. I almost call it smart chain there, on the blockchain, and interact with them from there. Anyways, I feel like this video is getting a little bit long from here. So if we deploy this contract, let's go and save this. Let's deploy this contract from here. And I promise we're getting back to that original contract to begin with. Confirm. Cool. So now that is done. Now what we're going to do from here on test 2, remember it's calling these functions on this contract from here. We can even see test is the same address that's right there. If we return the origin, now we can see the origin is still my address from there, that wallet address, because that's the one originally calling it. But the the return address here is the same. That's it. Phrase it right here. Return sender. The sender is this contract from here. So it started with my wallet, but the actual sender is this contract from here. So it's like a two-step process, if that makes any sense. Anyways, hopefully this all makes sense from here. What I'm going to do is I'm going to go ahead and we don't need test anymore. We're going to get rid of that here. And we can actually remove test2 from our deployed contracts because we're going to modify this a little bit here. Instead of doing a test here, we're going to import telephone .sol, and now we can rephrase this to be telephone. We're going to abbreviate that to be TP, which is kind of funny, but that's okay. TP. We can get rid of this function. We can rename this function here, and we'll call this change owner. We'll call it test change owner. Why don't we call it proxy change owner? Maybe that makes more sense. And then what we're going to do on TP, we're going to call it change owner. Now we need to give it an address here because it's looking for an address here. Let's just give it my address because we want to claim the ownership of that contract from there. So what we'll do is we'll just say MSG dot, here we'll say MSG.sender. And let's go ahead and save this. And we do have an issue from there. MSG.sender. What's the problem? Change owner. Nope, this one right here. Unnamed return. Oh, I'm sorry. We have to return this return something. No, I'm sorry. We need to remove this return statement from there. And this is no longer a view. It's just a public function. Cool. There we go. Forgot to remove that. Anyways, so now we're back to this here. We're going to save that one more time. And guys, I apologize. One more thing I forgot to do here is we're going to copy the telephone address and we're going to paste that right there because now we want to load the telephone contract at this address from there. So now let's deploy it. Actually, I don't even know if I saved that, so we're going to reject this transaction very quickly. Save, and then deploy it. And confirm. And we are almost there. Cool. So now that transaction went through. So now on test2 contract, we're going to call proxy change owner. And remember, this is looping back to that initial contract. Confirm. Where we change the owner, and because the transaction origin is different than the sender, we're going to set our address, the message sender address here, equal to the owner of the excuse me, I should rephrase it. The owner of the contract is going to be set equal to our address from there. Cool. Now that went through. Now if we go back to telephone and we look up the owner, now we see that this is the same address as our wallet. We can confirm that in here, in the console I should say. We see that's the same address as our wallet, or my wallet I should say. And let's submit this instance. And we are almost done, guys. Confirm. And we are all done. So we have completed this level here. A very simple level, but it's important to understand the difference between transaction origin and the message sender. All right. So if we go to the little example here, well, this example may seem simple. Confusing transaction origin with the message sender can lead to phishing style attacks such as this here. You guys can feel free to read up on this article on your own free time here. I'll leave this in the description. I think this video's got a little bit long here, so you guys can read this on your own. Basically, again, it's very important to understand the difference between transaction origin and the actual message sender here. All right, if you guys enjoyed this video, be sure to give me a thumbs up, comment down below, and subscribe. It definitely helps out the algorithm and helps me out to make more of these videos. And I hope you guys have a great day.